Just real quick, wanted to again remind everybody we'll be posting these videos on the VSF YouTube website or VSF YouTube channel, and on the VSF.TV website you'll have access to PDF presentations and links to the videos, all that other good stuff. Also, if you scan your badge at the main desk out there, please do that, and we'll also send you a link to the presentations when they get posted. So I'm very pleased to introduce Greg Shay, the CTO of the Telos Alliance, and he's going to talk us through some more aspects about containerization, and probably with a different, well, definitely with a different viewpoint than what we just had. So you'll, again, I think, learn some new vocabulary. So, Greg, take it away.
Okay, thank you, Wes. And thank you for having me follow Richard. Thank you, the prior presenter, because everything Richard said applies and is a perfect lead-in to what I'm going to talk about. Docker containers are a great thing, as Richard was outlining. And so what I'm going to go into is if you pull back the curtain, what are some of the things that don't quite work yet? And so I'm looking at, I've been doing investigation into the media over IP multicast hurdles in containerized platforms. So everybody's probably seen the little symbol for Docker. And I have a t-shirt I'll give away. If somebody knows his name, he has a name. Okay, so a clue. It is related to the most famous name of a whale. Close. Change one letter. So who said Moby Duck? Jason. No? Yes, okay. Here you go. He can get all the t-shirts he wants. Yes, Moby Duck. And here, I've turned his smile upside down because he's a little unhappy with all of the multicast going on. So, as Richard talked about, the first part, what I'd like to have you believe is, why is containerized software going to be important for the broadcast industry? And then what this problem is. I went into this, I thought this was great, let's use this, and I'm talking about putting our products in containerized software. And then I find out multicast doesn't work. And that's a pretty big problem, as you know. Most of what we do with media is over multicast. So I'm going to peel back those layers and get to the root of what's going on. So repeating some of the things from the prior presentation, I believe the biggest reason that containerized software is important and valuable is because this is the way that IT guys do their administration. This is the way they run their facilities. So if we're going to sell them any of our customers, they're going to have their facility run by the IT department. So we need to deliver our products in the way that the IT managers and the DevOps guys expect to use it. Containerized software is one of the main ways they do it. So as mentioned, some of the things that it does. So why? Why do they use containerized software? Well, the first reason is because it allows them to automate their operations. Think of it as software controlling software. So let that sink in a minute. These DevOps guys write scripts and software for controlling the software that's running. And that's literally what they do, and that's a good thing, because that's how, think of how when we have a product and you sell somebody a traditional device, and you have to go in and set up the configuration. You have to go into the user interface and put in all of that. That's how you automate that. It isn't that you have something going through and clicking with the mouse. It's done by scripts. So everything is writing code for configuration of the running of the software. That's what these systems like Kubernetes is all about. This is how Google Cloud works. I went to Google Next Developers Conference last summer, and if you've ever seen it, or if you haven't seen it, it's this huge infrastructure, an entire industry based around getting work done this way. One of the reasons, another reason a container is particularly attractive is if we are going to start selling products as software, one of the things you would like is if they want to run more than one copy, they can just fire up more than one copy. So the containerization allows you to break this association for a whole machine to do one job. If you need 10, you could run 10. It will consume CPU, but and you have to watch how much CPU you're using. But the basic idea is that you can run multiple copies of your product in multiple containers on the server that you have, and it'll consume resources as it goes. The other great thing about containerized software, again as touched on, is that in particular Docker has this really convenient delivery system for your software product called Docker Hub, and it's basically a software delivery surface in the sky, on the internet. And the way that that works is us as a developer and as a vendor, we test and ready to deliver the software, and we push to Docker Hub, and then at any time that the customer wants to use it, they just pull. So if you noticed the two lines that Richard showed, the first one to get the software was the Docker pull command, and you just give the name. So for instance, I have a beta project out there right now on Docker Hub under Telos Alliance called the IQV, and it is an actual back end of an audio mixer in a Docker container. This is how you deliver updates. So it's more than like an app store. It's for server software, allowing you to automate the update of the software. Now, what's the other way that we can deliver products as software? And that's using virtual machines. So I wanted to talk a little bit about what's the difference then between using containerized software and virtual machines, because a lot of times there are pros and cons, but it's helpful to understand. So the first thing is that Docker containers are lighter weight, meaning the files are smaller, it's not delivering a whole operating system, it's not allocating all of the resources that are in that machine. A virtual machine is more like here, I've given you a device, a whole machine, and it does this job. A Docker container is lighter weight. It's more like here is a process or a program to get this particular job done. Other differences are a container will use the network input-output of the host, whereas a virtual machine virtualizes and becomes the network I/O itself. So it is virtual machine encompasses and takes on more of all the network I/O. And this is actually kind of key to where I'm going with what's going on with the container. Another difference is, as I mentioned, if you want to make software as a product and hand it to your customer, and you want them to be able to go get it and use it with as little configuration as possible, part of the idea of a containerized delivery is you've given them the whole container of the function. You don't have to do that much setup. Virtual machines tend to need more configuration in terms of their environment and what they're doing. Even though the program inside is a whole machine, there tends to be more work to set it up and get it to work. So I touched on this already, but what's great about the Docker Hub delivery is it fits this modern idea of continuous integration, continuous development, which means that as a software provider, I'm not going through mailing people DVDs, I'm not going through even having to email them software updates. I am developing and testing my software, and when a version of software rolls out, it goes to Docker Hub delivery system, and then that's pulled down by our customers. When you're using Google services, Amazon, Amazon store. There are all kinds of updates going on behind the scenes that you don't even know. Now, it requires greater discipline on the behalf of the provider to, of course, only push out tested software, because you don't want to break everything. But this is the modern method. Well-tested, continuous, that's the continuous integration. You don't go through beta tests. You deliver what is known to work, and continuous delivery. Virtual machines don't quite have that level of smoothness of delivering. It's still a bit more like if I had to give you an update, I would have to give you another image. You would have to shut down the prior image and install and configure and run the new image. There is what's called a open virtualization format, which is a generic format for virtual images. If you know about virtual machines, there's a couple of different kinds. There's a couple of different vendors, VMware, Hyper-V, Zen, more coming out. And those are different. So if I want to give to you a virtual machine image, I would have to ask you which one. The open virtualization format fortunately exists, and these vendors of the virtual machines import from that open virtualization format. So at least that hurdle is down, but they lack this mechanism, this Docker Hub delivery mechanism. So to dive into the problem, my wish, what I'm trying to do, is I want to use the containerized software for delivery of my broadcast audio processing products, and take advantage of all of these features that I was just talking about. So what's the problem? And as I alluded to, multicast does not work with Docker. So why? I'm going to peel that onion. So I'm really amazed that anybody's interested in this, because this is quite gnarly and whatever. But anyways, forewarned is forearmed, and I didn't know. I didn't know why it didn't work. I figured if I took the time to figure out why and understand that it might be useful, and I would talk about it. So the first thing to understand is how Docker works, okay? From the outside, it may seem like it's the same thing. It's just another format of a virtual machine. But how it does its magic is Docker isn't a virtual machine. It uses the Linux kernel namespace feature. So what that means is you're essentially running a program, and everything having to do with that program, all of its sockets, all of its OS resources, all of its processes, everything is its own, has a tag, a name on it, so it's its own. So it gets the isolation. So no other programs that you run on that machine can get in the way. It has essentially the machine to itself. In fact, they even end up with isolated named network interfaces. If you look into a running system that's running the Docker engine and running a container, you'll see your physical network ports, but in that same list, you'll see other names of network ports, and you'll say, where did these come from? These are the things that the Docker launching program, that the Docker engine created, which that container uses, and it doesn't use any of the others. So this is another technical difference between a VM and the containerized software, because VMs actually can virtualize and emulate the actual network interface card. Docker doesn't do that. It uses the mechanism that's already in the kernel to give it a private network interface. So this is actually the root of the problem of why multicast doesn't work, because the Linux kernel handles multicast in a specific way, which doesn't help us. So the root of the problem actually goes back to the Linux kernel. So some of the things, because Docker is relying on the Linux kernel to do the routing, some of the things that the Linux kernel does that are not working for multicast is you can't nail up a fixed multicast route, which most of the time would be a fix for the problem. But that's not the way the kernel was designed. I can try to rewrite the kernel, but that's not very effective for my customer. Hey, Mr. Customer, you know, you have to hack your kernel for every hosting machine and all your servers. You know, I'll hack your OS for your servers, right? No problem. So multicast routing in the Linux kernel is done dynamically, so you have to run a process which responds on the fly to what is going on and setting up those routing rules. Now, here's another further difficulty, understanding the difference between multicast routing and snooping. The kernel is assuming that it's doing multicast routing, and multicast routing means you configure endpoints, and you have to know about, okay, I'm an endpoint, and you want to get these particular multicast channels, and that guy over there wants these other channels. But the point is, there's an amount of configuration that has to be done on the host. So this breaks the containerization again. So no matter what I do, I still end up having to configure the host. I don't want to have to configure the containerization host. And then you may say, well, how have things been working? How does everything in this room and everything next door and audio over IP for 20 years now has been working? What have we been doing? And the answer is, all along we've been using what's called snooping, layer 3 snooping switches. And it's a little bit of magic, but it's been standard. And the network switches are paying attention to the multicast protocol, to IGMP that's going on. The courier is asking, okay, everybody tell me about which multicast channels you're interested in. All the devices subscribe to what channels they're interested in. The switches let those messages go through. They read them. They program themselves to send the multicast to the right ports. But they're kind of silent about it. They're not routing, they're snooping. So this is part of the answer. What I would really like is that the Docker host machine would act as a layer 3 snooping switch. If it would do that, then I could put multiple Docker containers as media devices. They could do what they've always done, subscribe to multicast, and they would get the work done. But that's not the way the kernel is designed. In fact, I tried some experiments. Okay, let's try to coerce the kernel to let the IGMP multicast control through, and it won't, because it knows it's being a router, and the rules about routing are you don't pass the subscriptions through, because that's a different routing domain. So the kernel actually goes out of its way not to allow this. And like I said, can't hack the kernel as a solution. So what to do? Well, there is a shortcut. And the previous gentleman, if you again noticed very closely on his slide, the second line, he was using this shortcut. So one of the shortcuts is, if you run the container with this command called net equals host, then what happens, you're telling the container, take over and use the network of the host, and guess what? Multicast works. So, but, there's always a but. This is a problem because now that container has the IP address of the host, and all of the ports are directly there on the host network. So it breaks this thing that I want, that if I want 3 of my audio processors, I would just fire up 3 containers, and you would be able to use them independently. So that gets broken with this shortcut, which again defeats the purpose of doing the containerized software. So what else might we be able to do? So I'll jump ahead and tell you, I'm not going to tell you the answer. This is an unsolved problem, at least for me, as of so far. So I'm leading to what are some of the directions. So there is a suggestion that says, okay, well, we can solve this if for every container we wrap a virtual machine around every container just to solve this multicasting problem. And each virtual machine then you can configure with its own IP address and all that. This will work. It's adding more complexity. And my problem with that solution is it breaks this nice ability to use Docker Hub, and I publish the software and then you use it, because now it says you have to go get that software, you have to wrap it in the virtual machine and configure that virtual machine and configure the software switch that's in the virtual machine host. So it's kind of a half solution, but I'm not quite satisfied yet. So this direction I'm still looking at, and I'm sure maybe some others are. So my between the line strategy here is I'm hoping somebody else that connects with who's working on the same problem. And I looked through all the list of all the presenters, and I was hoping to see somebody who knew how to make this work. I'm willing to be wrong. But how to make the Linux kernel, the IP tables routing inside the kernel act as a layer 3 snooping switch. So I'm not there yet. I figured I've moved the ball forward. Sometimes, if you can't solve the problem, well, one of two things. You either figure out the problem or you prove it can't be done, right? And I haven't got there yet. I haven't proved it can't be done. I see what the Linux kernel is doing. So, a second t-shirt. I can think of another solution, and if somebody can tell me what I'm thinking, it's actually a fairly obvious solution, and then I'll tell a story why that's so important to me. The whole problem statement, what I'm trying to do, who can think? What's another possible way out? Okay. That's not what I was thinking, but I'll give you the shirt if nobody else gets what I was thinking. So you said use a different type of containerization. Yeah. Oh, okay. So a different host, a different Docker engine host. That's fixed. Okay. Well, write one and I'll use it. I'll buy it from you. Say again?
Having a virtual switch.
A virtual switch, well, is actually in virtual machines. So VMware has a virtual switch. And the difficulty is if I'm going to give you my product and then you also have to then configure that virtual switch, it's not kind of a self-contained solution delivered to you. So a clue, this thing that I'm thinking of has to do with my whole problem statement. What if I don't use multicast? What else could I do?
SIP.
There you go. He gets the t-shirt. Here, Wes.
I was saying that you can use unicast.
Yes, thank you. Now the story. The reason that's a big deal for me is I was on the AES 67 committee, what helped create AES 67, coming from our prior work with Livewire, which was really started 20 years ago. I was one of the people on the AES 67 committee who pushed very strongly to get the AES 67 unicast mode in the spec to make it mandatory. And there's been a lot of back and forth, and I can't say that I've always been on the majority side of the opinion, but we got it in there. And the reason is because I knew that audio over IP in AES 67 is going to be useful in more than just your local LAN. It has a future, connections over the WAN. In this case, this kind of took me by surprise because this allows it to get through firewalls, it allows it to get into the cloud, it allows it to be containerized. So we have to remember that when following IT technology, we have to be careful not to go off on some tangent that might be convenient for us, multicast. We have to really stick to, how does the web work? The global internet and web is not multicast. It's all unicast. So that's my point. We can solve this if we use unicast mode. I actually was rather disappointed when SMPTE 2110-30 right off the bat says multicast only. We don't have to do unicast. I think that was a mistake. I think there is a future for unicast in media over IP. And that's my presentation.
Well, thank you, Greg. So now it's your chance to ask him questions, but I don't think you have to give him a T-shirt. So do we have any questions here? One thing I would like to point out, Greg, is that right now, I mean, this very month, SMPTE is looking, 32NF is looking at the one-year review of ST 2110-30.
Ah, okay.
So if there's something that you think needs to
Yes.
be changed in there,
I better get on a plane.
your time to speak up is now.
Yeah, understood.
It's not
Sure.
not some arbitrary point in the future. But if that's something that you think is a major issue, let the team know.
Yeah.
You know, I'll try to alert some folks, but it'd be a lot more impactful coming from you.
Sure.
So, any questions? Anybody? Anything? Got any more T-shirts? No.
Yeah, come to the Telos booth, we do.
All right, good.
And if you need a different size, come and get a different size.
Okay, great. Well, thank you very much, and we'll be set up for our final speaker of the day in a couple minutes.